In this video, I will go over the homework that follows the lecture on Introduction to Inverse Trigonometric Functions, and as always, I hope you watched all these videos, and I expect you to be familiar with all 6 inverse trigonometric functions. So let's go ahead and get right into the homework and see what type of problems we are expected to do. So first problem is we have cotangent inverse of cotangent of 5 pi over 3, and as it can be very tempting to just, reduce this, we cannot do that for the same reason we cannot do this when working with composition of inverse functions. You cannot reduce this and this because that will imply that the answer is -2, but the domain of the radical function is only positive values. So how do we answer this question? Well, first we need to check the domain of cotangent inverse. And what's the domain of cotangent inverse? The answer is right here. So the domain of cotangent inverse is from, I'm sorry, not the domain, the range. We're looking for the range in which the outputs of cotangent inverse are expected to be in. And it says 0 to pi. So we expect whatever this number is to be between 0 and pi. So we're looking for some value whose cotangent is, well, it's fair to say we can label it as theta, but it doesn't matter. So we're looking for theta whose cotangent is equal to cotangent of 5 pi over 3, but the angle itself is between 0 and pi. And it's just a matter, I guess, of understanding what this angle is. So let's just sketch a quick unit circle, or just a circle. Where's 5 pi over 3? This is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, right here. So you see how 5 pi over 3 is right over here. And we want, what's the cotangent of 5 pi over 3? It's the cosine of 5 pi over 3 divided by sine of 5 pi over 3. So I think what's important here is that it's going to be cosine of 5 pi over 3, it's 1/2. Sine of 5 pi over 3, it's -√3 over 2. So the question is, for which angle between 0 and pi, cotangent is going to be the same as this one? And the answer is, it's going to be the angle in second quadrant, and it's going to be precisely this angle right over here. So the answer is 2 pi over 3. So let's do 2 pi over 3. Similar problem, but with sine. So we have sine inverse of sine of 4 pi over 3, and the range of sine inverse we can check. The range of sine inverse is from -pi over 2 to pi over 2. So whatever this answer is, we can label it as theta. Theta must be between pi over 2 and -pi over 2. And sine of theta has to be equal to sine of 4 pi over 3. So again, sketching a quick unit circle, 4 pi over 3 is right over here. And sine of 4 pi over 3 is the y coordinate, and the question is which angle between negative pi over 2 and positive pi over 2. So which angle in these two quadrants has the same sign? And the answer is it's going to be the negative pi over 3. So this angle has exactly the same sign as this angle. But this angle satisfies this condition. So the answer is negative pi over 3. We have cosecant inverse of cosecant 4 pi over 3. The range of cosecant inverse function is so the range of this function is from negative pi over 2 to pi over 2 except 0. It cannot be equal to 0. So it has to be from pi over 2 to negative pi over 2, and it cannot be equal to 0. So these are the conditions that theta has to satisfy. In addition to cosecant of theta has to be equal to cosecant of 4 pi over 3. Now, an alternative approach to unit circle will be to actually graph this function, and let's go here and try Desmos. So we're looking for a value between negative pi over 2 and pi over 2 that is equal to cosecant of 4 pi over 3. So let's graph the function. So we have cosecant of x. We want the output to be equal to cosecant of 4 pi over 3. But we want our x to be between negative pi over 2 and pi over 2. So this is what we're doing. And the question is, for which value in this range the cosecant is equal to the cosecant of 4 pi over 3. And you can see that it's negative pi over 3. So this is the answer. I think I accidentally closed out the homework. Did I? So the answer here is negative pi over 3. So the range of cosecant again is from pi over 2 to negative pi over 2. Theta cannot be equal to 0, but cosecant of theta must be equal to cosecant of 5 pi over 3. And I'm going to use Desmos again because it just seems to be easier. So I'm going to change this 4 to 5. And the answer is now negative pi over 3. Again, hold on, did anything change? Changing 4 pi over 3 to... because the cosecant of 4 pi over 3 and 5 pi over 3 is the same, so nothing changes here. The answer is still negative pi over 3. That makes sense. We have these expressions that we have seen before. There's a certain steps that we take to simplify them. And the first step is to introduce angle theta, so that the problem is now very simple. It's cosecant of theta. But what is theta? Theta is a value whose cotangent is equal to 3x minus 4. And I'm going to write it over 1. And now we're going to use the definitions of cosecant and cotangent to introduce the reference triangle. Cotangent is adjacent over opposite, and cosecant is hypotenuse over adjacent. So we're going to draw a triangle, and we're going to use with angle theta, and we're going to use this to label the opposite side as 1, the adjacent side as 3x minus 4, and then we're going to use the Pythagorean theorem to find the hypotenuse. And now we are ready to write the answer. So the cosecant theta will be the hypotenuse, which is 3x minus 4 squared plus 1, divided by adjacent side, which is 3x minus 4. So let's type the answer. We have square root of 3x minus 4 squared plus 1, all that divided by 3x minus 4. So let's see if we got the right answer. Cosecant is, I guess it doesn't help to make this silly mistakes. Cosecant is actually over the opposite side, right? So we divide over 1. All right, let's do another one. It's again standard problem, standard procedure. Introduce angle theta. The problem is very simple. I need cosine of theta. Cosine of theta is adjacent over hypotenuse. So we draw a triangle. Here's theta, here's adjacent, here's hypotenuse, here's the opposite side, but I don't know any of these sides. So I need to use the fact that cotangent of theta is 5x minus 4 over 1, but cotangent is the adjacent over opposite, so I'm going to label my adjacent side as 5x minus 4. I'm going to label the opposite as 1, and by Pythagorean theorem, the hypotenuse is square root of 5x minus 4 squared plus 1. And I'm ready to write the answer. It's going to be adjacent side, 5x minus 4, divided by the hypotenuse side, which is square root of 5x minus 4 squared plus 1. We have another one. We have cosecant of cosine inverse 2x minus 4. We introduce angle theta. The problem is simple. We have to find cosecant of theta. Cosecant of theta is hypotenuse over opposite. I'm sorry, right, so this is cosecant. And we need to draw a triangle with angle theta. This is my adjacent, this is my opposite, this is my hypotenuse. And now I'm going to use the fact that cosine of theta is equal to 2x minus 4 over 1. And the fact that cosine is adjacent over hypotenuse. So I'm going to label the hypotenuse as 1 and adjacent side as 2x minus 4. And then by Pythagorean theorem, the opposite side will be 1 minus, well, the square root of 1 minus the square of 2x minus 4. So the answer is 1 over the square root of 1 minus 2x minus 4 squared. So 1 divided by square root of 1 minus 2x minus 4 squared. We have tangent secant inverse of 4x plus 2. And we introduce angle theta. So the problem is easy now. Tangent theta, which is opposite over adjacent. We draw a triangle. This is my opposite, this is my adjacent, this is my hypotenuse. Now we're going to use the fact that secant theta is 4x plus 2 over 1, and the fact that secant theta is hypotenuse over adjacent. And I'm going to label the hypotenuse as 4x plus 2 and adjacent as 1. Then by Pythagorean theorem, I'm going to use the Pythagorean theorem to find the opposite side. And now I'm going to write the answer. So it's going to be square root of 4x plus 2 squared minus 1 divided by 1. So it's just going to be the square root of 4x plus 2 squared minus 1. And we finished it. So if you have any questions about this homework, please reach out.